Great. So what we're gonna do today, as I mentioned earlier, so we already done the face milling. You can see, so that was the face milling we've done, and that was the process on the top of the plate. We've done it as a face milling finishing, but of course, if you want to have a cleaner look, you can always have a roughing, which removes more material, and then you can do a slow kind of finishing on top, which we'll be able to do with the face milling. Then we continued by creating doing the milling in these two pockets by the method of roughing. So we use those, and in order to operate, once we've done the operation, we created the kind of sub geometry. And if I go here, we created that kind of sub geometry for the milling area under the needs of the workpiece. And then we processed that one as a roughing, as I mentioned. And also we've done the finishing to have a clean look for both the flooring and the wall. And what we learned that once you do, for instance, the floor finishing, you can always copy and paste it and create the walls and then come back and then modify those parameters. So these software you can use copy and paste, but make sure whenever you do that, you have to come back to that operation to check everything is correct. So if I come here to the machining tool view, what I would be able to see, so far I have two tools. The first tool, if you remember, we loaded, we retrieved it from the library, and we've done a face milling. The second tool, it was something we created. It's an end mill 22 millimeter, and we use the same tool to do all these kind of operation, from the roughing to the finishing of the floor and walls, both of them. For every single process, if you remember, there was some sequence of doing that within the CAM. So first of all, you have to make sure that you have a correct setup. And I received a couple of emails from your colleagues that they had issues. And I really recommend to come back to those videos, because having a correct setup is really important. Otherwise, the software won't be able to continue. So defining the coordination systems, defining the workpiece, defining the bounding block is really important. And also if you have a sub kind of, geometry is really important. Once we set up the CAM machine, then for every sort of operation, we need to make sure we already have the tool. We either retrieve it or we create it. And once we have it, then we start doing the operation on that. If the sub geometry is required, we do the sub geometry first, create the tool, assign it to that sub geometry, and then create the operation. If this one is not required, we already have the geometry, we go with the creating tool, and also we create the operation. So these sort of sequence of following it. But one of the benefits of using NX is it has its own kind of artificial intelligence embedded to it. And that's one of the reasons it's quite well known. It's not only for that, the other sub has these features as well, but NX is one of the best one. And what I'm gonna do today, I'm gonna go through the knowledge-based system. A knowledge-based system is basically you set up the machine and you wanna let the machine to decide for you what's the best methods of manufacturing it, which is what you're gonna learn by today. It's fascinating, to be honest. It will change your mind about every single process. But if I started delivering that in the first session, you might, first of all, you didn't know what's going on for every single of these, and you might question why I should know these processes, because NX will do everything for me. But now, because you already know how you're going to do it manually, then it would be easier for you to understand what the machine is trying to do. So in order to work with the machine right now, I have to tell the machine that what kind of features I'm interested to NX go and do an operation for me. So in order to do that, I have to find those features. And what I'm gonna do, I'm gonna go and work on these holes and start doing the operation on that. So these holes, and you can see in terms of the kind of the operation arm I think about. So these holes, 1, 2, 3, 4, 5, they have the same length, the same width, and the 4 outside, they have the same width as well, same diameter. However, if you look closely, you can see the one in the corner, they have the countable as well. So it should be a 2 different process of doing it. So once I do the top one, then I go to the inside of it. So this is what I think. But rather than I do it manually, I'm gonna use the knowledge-based a knowledge of the NX, which call it the knowledge-based machining. So in order to do that, I need to go to the machining feature navigator. So you can follow me right now. You can listen to what I'm doing, and then I will give you time to do it at your own time, and I will repeat it one more time. But because I'm recording this one, I'm gonna keep it short and sweet, so I'll just go straight to demonstrating it for you. So you need to go to the machining feature navigator, and if I click on the plus, you can see I have my part, but there is not features attached to it. So what I will do, I will just click here, and I will make sure I'm in the home, and there's a button called Find Features, or you can right click, and you see the only option right now is Find Features because you are into the feature section. If I click there, there are the different things you need to set up. First, make sure you're gonna tick the parameter recognition, because we're gonna work with these kind of parametric. And the search methods, you can have it on the all geometry workpiece. It's okay. Let's go with the workpiece. So I'm gonna pick, if you have the assembly, then you have the few parts you're gonna pick. I'm gonna pick the workpiece that I'm gonna work with. And also make sure this one, the parameter feature, is tick. And if I tick this one, it shows me all of these features: bosses, grooves, holes, pockets. But basically, if you're only aiming for the holes, you can tick the holes, for instance. But let's go to find how many features I have from it. But if you dedicatedly sure what you're gonna do, you can pick it from here. But I prefer to go with the parameter features subgroup. And then what I need to do, I need to click on Find Features. Let's see how many features it finds. It finds plenty of features for me. The thing is only important for me is just these step holes. So what I'm gonna do, I'm gonna pick the one that I'm not interested. You can hold Shift to have taken more. But basically, if I pick every single of these, you can have a look at that. So for instance, that's one, I don't need it. I click on Delete. I don't need this one, I remove. And I don't need none of these, and I will remove. So basically at the end, you should have 9 holes. 1, 2, 3, 4, 5, 6, 7, 8, which is the one at the back, and a 9. And also remember the sequence of it, because based on these kind of features, the machine gonna work with those in terms of sequence of numbers. But it's okay right now. For now, it's okay. We found 9 holes that we're gonna work with, and I click OK. So if I click OK, you can see that I created 9 holes as a features under the injection clamp plate. So what I'm gonna do now, I'm gonna use the AI part of the machine to create the operation based on these holes. So I'm gonna ask the machine, what do you think? What's the best method of manufacturing? So what I can do, I can hold the shift and I pick all of these, and I would be able to go to the create feature process. And if I click there, then I will make sure I'm gonna tick the rule based, and I will tick the mill drilling, and let's pick everything, the full drilling category, because I want to ask the machine what it thinks for me. For instance, whether it wants to do a drilling, normal drilling, you want to create a tab, you want to do the contesting, whatever. You decide for me which one I want to do. And make sure you define the geometry as a workpiece, not any other things, because we have the sub geometry, if you remember. I'm going to pick the workpiece, and I'll click OK. So once I will repeat it one more time because one of your friends asking, you click here, you go to create features, make sure it's a rule based, make sure the mill drilling is ticked. And if you tick the mill drilling, because the higher level, it will tick all of these drillings category for you, and you click OK. So if you come here, you can see for each specific hole, it created operation. So if I go back to the operation navigator, you can see it created these programs for me. So for instance, it created a program for this one, that one as a spot drill. So it thinks that you need to have a spot drill. And the workpiece, yes, regarding your questions, the geometry is workpiece. And then it thinks you need to have a drilling one by one. And then because those for, if you run, is a counterbore, so it's a counterbore drilling, and then you do a finishing for the mid one. But these are, you can see these signs next to it. The reason we have those signs, because it's not generated. What I can do, I can go to the higher level, right click, click on generate if I want to generate everything. Or if I want to pick every sort of group, I can come here and click generate. So let's go and click on generate everything. And then it asks me, are you sure about these paths? Because it wants to create some kind of operation path. So I'm just saying, yeah, I'm happy with whatever you're gonna recommend me. So let's okay and accept it. And now let me go to the spot drills and then I will visualize everything. So what I'm gonna do, I'm gonna go there, right click, and I'm gonna go to the toolpath and verify because I want to see what it's going to do. Let's have a look. Doing the spot drill for the 4 outside. The spot drilling is done. I'm gonna go with the drilling. And let's go and verify it. And now it wants to do a drilling. It keeps changing the tools if you notice. It kept changing the how much is the depth required to do. Let's see what it's gonna do with the counter bore. So if you've seen it already done the drilling on the top, but now we're gonna go and clean it. You see that? So it's done the hole first, and now we're gonna create the a counter bore. And now at the end, what it does, it goes and do the process for the last one. As simple as that. It's done everything for me, and creating those, how long does it take? Especially if you're new, it will take a long time for you because you have to define the tools and you have to go through the processes. So let me go in here and you can see it automatically realized that it should put them into the different pockets, and it created tools for me. So that's the tool is required for this one. I've done this with spot drilling 1, spot drilling this one, and spot drilling for that one. Same thing for pocket. We created a tool, doing a drilling in the center, pocket 5, do another drilling, and also it continues. So everything seems to be ready, but it created a sub. I've noticed I've been muted. Hopefully, it's not a long time that I'm muted. Up to what part did you hear me? I've just noticed that actually the mute button appeared for me.
You heard only
did you hear it?
The last couple sentences.
Okay, couple of sentences. Okay, great. Thank you so much. Yeah. So if you notice that it automatically created the tools for me, and also it assigned them for each specific operation. So what it does, the same way that actually you think about it. So it created the tool for you. Yes. Cool.
What did you just create? You just created some tools for the holes. Can you go through that again, please?
Yes, I will go. Yeah, I will go one more time slowly because I know I went fast. Yeah, sure. So the same way that actually you think about it, created the tools, it creates the operation for you. And you think about what kind of operation is required. These things you need to have experience to make sure what kind of operation you need to go for. But whereas in here, it already and automatically find it out that which one is suitable to do. So what I recommend then, once you finish those, because it's part of sub-program and you don't want to showcase that actually software done it, you can always pick those and bring it back to the actual software and take it out of these groups and bring it here and bring it here, and then you can remove these are just the categories, and then you have everything. I would be able to go there and I can go and generate everything. And accept the path, and it's ready to go. So let's keep it for now, and I'm gonna pause the recording, repeat it one more time slowly, and then I will go back to this one because you have to modify something. It's done everything, but it's not perfect. You have to do some kind of modification to that. That's why that's quite interesting. Actually, Eric knows the G codes. Definitely, once I go through the G codes, it would be quite good to have you on board as well. So let me go to the next step. So what we've done, we already created the operations through the AI. Now what I'm gonna do, I'm gonna make sure that what kind of processes is done properly. So technically, I'm gonna have a look to the process. So what I can do, I will go there, right click, and then click on the if my mouse, let's say, generate, accept the path. It will generate the process for everything, and then let's verify it as well. So I go to the toolpath, we'll click on verify, and let's let me pick it up at the beginning and play it. So I'm doing the face milling, and if you see, it's a face milling finishing method, so it's not roughing. And you do and then what they're gonna do, I'm gonna go to these two pockets, and it's a roughing. And you can see once it go that, it do the flooring and also do a wall, which is the finishing one. So that's the finishing. So far was roughing. You see that? It's speed is changing, and then it goes to the floor and then the wall. And now do a spot drilling. From now on is what the AI values from us. Previously it was what we've done, and you can see done the spot drilling, do a drill one more time to make sure the bit is the same. And then these are the content songs. So you do the top and then go and do the bottom one and do a process on the middle. So everything seems to be fine. Something, as I mentioned earlier, because these are done with the AI, for instance, this one I've done it manually, so I followed every sequence. The method, I know what method is going to do. I've done that, and I've already defined the feed and the speed, right? However, for the one that software done it for me, it doesn't know what's the feed and the speed I'm looking for. That's why for every single of these, for these one that the knowledge base part of the software done it for me, I don't have those information. So for instance, here, the method is empty. I can go back to it and add the method, but the most important one is this one, the feed and the speed is 0. For your assignment, you already have the feed and the speed, which you can put it there. Call, yes, please. Do you have a question?
Yeah, have we gone through the spot drilling yet?
With the spot drilling is the one that you automatically created with the feature recognition.
Oh, okay. So we don't need to do anything with it. Why have I got a load of those warning signs next to them that I guess say that I can't really do it?
If you see any kind of those signs,
I don't know if it's because I didn't save the other process, or does the other process have anything to do with it?
You haven't generated it. So what you need to do, you need to click on every single of them, or it's better to go to your name of application, the name of the code. It can be 1, 2, 3, 4, plate, meaning whatever. Right click, click on generate.
Okay. Okay. Generate. Okay. Right. Okay.
Yes, Eric. Yeah.
Yeah. Okay. It's generated, I think. Thank you.
Great. And what when you've done that, it's what I want to say. Yeah, you make sure actually you've done everything. So and in your case for the assignment, you already have the feed and speed they already gave to you. You just need to put them in here, and then make sure once you put the numbers in here, make sure you come back click on generate and verify. Or just change the numbers, click OK, and come back here and then regenerate it and then re-verify it to make sure then the total time would be updated, because the total time of operation here is based on the default feed and speed. It's not the actual feed and speed on the machine that you need to work with. So it will change the timing in here. So once you've done that, something before I forgot to regarding report, because I've noticed for the first assignment, some of you just uploaded parts without any kind of report attached to it. It had the calculation for the design elements, but nothing on the parts. So please make sure that you write a paragraph for each of these kind of specific operations. Don't just upload the file. Having the file is just for us to check whether you made the report and you've done it correctly. But if you just upload the part, especially in this case, because AI gonna do everything for you, right? So please make sure actually you write the proper report, paragraph for every single process, so we know that what you are doing. So you can say, I've defined a setup by doing that, blah blah blah. I've done the banding block. That's a picture screen of it. Then I went through the next steps. So I followed the creating tool. Then I created the operation. That's the operation. That's the tool is used. Why I've used that tool. These sort of things. Great. So now let's go to the other part of it. And by the way, if you want to go, you already have the recording of drilling the holes. But basically, even this file goes through it section by section. And now what we're going to do, we're going to start engraving the operation. So in order to do that, I have to have a text I want to engrave. So let's go to the geometry. And let's go to where it says point. And pick a node. So technically, I'm adding something to the CAD geometry I have. And with the nodes, write your name, whatever. I'm going to put Esfandiar. And in order to change the font of it, you can go to the setting. I think in your case, the way you see it, it's like that, I guess. Make sure you go to setting. Go to the setting again, and you can see there's a font here and there is a height. If I remember correctly from the tutorial, I think the height didn't ask you to change it to the 10. Okay, it says font 10, so it means the height should be 10. Change this one to 10 and close it and leave it. Let's say I'm gonna leave it there, but wherever you want, and click close. So what I've done, I just added a text to it. It can be the name of your group, it can be your name, whatever. And now what I'm gonna do, I'm gonna get an operation out of it. So what I want to do, wants to go, let's go here and let's go there. So first of all, I know where I want to operate is a pocket 10 because I've already done everything to pocket 9. So I know I want to work on the pocket 10. Again, because I'm gonna do it manually. In order to do that, I have to know what kind of tool I'm gonna use. Either retrieve it or gonna create a tool. I'm gonna create a tool this time. So I'll go and click on the creating tool. But if right now it should be hole making because you already went to the hole creating holes, it thinks that you want to continue with the creating hole. Let's go back to the meal planner, the first one. And I'll go and pick the normal milling again. And make sure you put in the pocket 10. In my case, it's pocket 10. In your case, might be different because you may not do all of these processes. Put it on the next available pocket, let's say. You can always move it around, don't worry about it. And let's change the name. I don't know. Let's put it text mail, for instance. Text mail. And in terms of the dimension, this is what the tutorial asks you to put. A diameter 0.5. And then what I have, taper angle is this one. That angle is 15, so become narrow compound like that. And you can see that actually that one is that gives that kind of angle to it. A length is 75 by default. That's been changed to 50. And flute So the fluid is important because this is the one that actually do the cutting. So that's that. And the fluid is 10. How many fluids? It's okay, 2. Let's have 2. And click, and material is HSS as well. So I don't change the material. If you want, you can change the material as well, but that's okay. Click OK. You can see I already have the pocket 10, and that's the tool I created. If you want to move it around to any other pockets, you can always would be able to pick it up and put in, let's say, pocket 12, if in case you have it on the wrong pocket. Then make sure I put in a pocket 10. And now what I'm gonna do, I'm gonna create an operation like before because I'm doing it manually. What I can do, I will go to the create operation. Yeah, sure, Samuel, I will do it one more time for you. And then go to the create operation. And once you go to the create operation, make sure you enter the meal planner. By default, you're in the first one, floor and walls. Do you remember that? Now you're gonna go to this one, which has the a text next to it, a next to it, which is a planner text. Program, make sure you pick the program, 1, 2, 3, 4, whatever you name it. In my case, the plate milling. A tool, the tool you just created. So this one you created for doing the what was it? The drafting, and the rest, these are the face milling. That was for the face milling, and the rest, these are the one that you created for the holes automatically. I'm gonna pick the one that I just created, which is a text mill. Geometry, I want to apply it on the workpiece. The method is the mill finish as well, because I want to do it in one single operation. If you want to do it in the different operations, a semi-finish and a finish, you will do it. We're gonna do it with one process. It's just a normal engraving. Planner text, I'm happy with that, and I click OK. So once I go there, same as before, make sure geometry is defined as a workpiece. Now I have to tell the machine where is my text. Click on that text. So don't worry if I go it so fast. I'll do it one more time. I just, because I'm recording, I want to make sure that you have a short recording so you can always go through it. Pick the text. Okay. So you already have the text. You can see, I can highlight it, and I have to specify the floor. So the machine realizes where it needs to start the cutting. So I click on the specify floor, and I need to pick that floor. In order to do that, there are different ways. So I think it's the YZ, not this one, not that. 0. XY. Make sure you pick that plane. This stand is 0, and I click OK. So I know the text, I know where it wants to operate. The method is mill finish. Text depth, let's change it to 0.3. So this is what you say. And also depth per cut, the same things. Oh, I think it's 3. Let me double check. I think it's 3. I've done that. We've done that part as well. Yeah, 3. Okay. So once you've done that, then you can click on generate. You can see create a toolpath, and let's verify. Let's have a look how it's going to do it as well. I have a long name, so it takes longer. And then click OK. And OK. So that was how you would be able to create a text on the CAD geometry, and how you can create the operation for it. And you can see here, if I come here, the planner text, that's another set of code is added, and the tool is a text milling. And if I go here, you can see underneath of these geometry after the step hole, I have the planner text. Great. Post-processing, I want to mention a couple of methods on doing the kind of optimization before I go to the post-processing. Good. Because I received a couple of emails from your friends about how do you find those feed and speeds, and I want to tell you. So basically, if I know the machine, if I specify the machine, whenever I go to every single of these process, I would be able to set the machining data here, and I would be able to get this information. But if I do it now, because it's not set up there, it should show me an error that because cutting method is not defined, and I have to go and modify it. Basically, it's better to calculate the surface speed and also feed per thus, and then click on the calculator to get these sort of information from it. which is what we've done for every single of these activities that we've done before. So you can see all of those. I put the surface speed, feed pathos, and I click on the calculations, and I got the spindle speed. But basically, if you want to ask the people who work in industry or technician, they have the handbook. Usually they go for. So if you go to Google and if you search for CNC CNC feed rate calculator, CNC cookbook is a really, we have the book of that one in the Roehampton Vale Library as well. It's a really good book. So it has all these sort of information there, how they write the G codes, how they set up the CNC machines, how do you calculate these. There are lots of formula there. It's a really good book. I highly recommend. Now, whenever you came back to the RV, make sure you go and have a look at it. It's quite interesting. You can see in here, I have the calculator. I can give the diameter that I have, and then I put these to be able to do the calculator. But basically something I was interested, let me share the link for you as well in here. I cannot because you're seeing my Mac machines. I'm sharing my Windows machine. So I will share the link later for you. You can see these one based on a different material, they recommend the surface speed. And this is what they have in their handbook. So if you have an expert, a technician, they already know what kind of numbers they would expect to put it there. And then they will check if the machine would be able to do that or not. Of course, the machine would be able to operate. They can do it way faster than these numbers. And you can see they have all of these sort of things based on the process. So I really recommend this one to go through. This is just additional information for you if you want to learn more about it. This is not about coursework. And this is something that is useful for you. If you go even to here, there are some PDFs, some of them they're free, but as I mentioned, at the RV, we have all the books free of charge. You can go there and have a look. But what I'm gonna do, so that's for that. And I'm gonna talk about some kind of, feature recognition we've done so far. And you can see these ones, we would be able to optimize it. And I'm gonna do a couple of them for you so you can understand it better, and then I will give you a link to the YouTube video. So they've done a few of those. These are the things, as I mentioned, it's for additional knowledge. It's not something that I'm going to teach you because it would it may be confusing and you don't need it for your level. Well, of course, if you're interested to work in the CAM area, if you want to do it in your industrial experience, that's something good to know. If I go to each of these processes, let me go to here, for instance. And you can see if done that process, and as a part of even assignment, I ask you, you need to optimize it. The machine see a thing it needs to do that operation, right? But now I'm gonna challenge it in a way that you went from this hole to this hole, and from this hole to this hole, and you got a timing for it, right? You got the timing for that to do the process for 42. 37 seconds cutting, 5 seconds non-cutting. So I'm trying to optimize that 5 seconds non-cutting. I might tell you why you didn't stop from here to go there and then continue with the rest. Is the same things. Or why you didn't do it like it going there, doing the zig and doing there. Technically, if I go from here to here, and then if I do that kind of zig move, because it's in the 45 degrees that I can do the G00, we put it the rapid move. It goes as fast as possible because in the 45 degrees. So what it does, it goes there and then go a cut there and then do a cut. So it can do that. But usually the change is marginal. But once you go with the more holes on the sides, then doing those kind of things is important. Why shouldn't do that? Especially in your assignment, you have several holes. Do you have any idea? I want to ask you why the machine picked that one. Do you think it's because the machine think that is the best option for you? Diagonal is longer distance, right? So it will impact the non-cutting. Well done, Jeff. What else? Eric, yes, please.
Well, it's like you say, when the machine is traveling at 45 degrees, it can travel at the highest speed, which means it can use, but it turns both of the lead screws of the axis to move to to move the cutter faster, ergo you get faster movement and less wasted time traveling, I suppose.
Yes, you're absolutely right. Exactly. So the machine, once it realizes that, it goes through all those processes. The longer distance, which one is the faster, and also, as Charlie mentioned, it picked the shortest path as well. The reason for it, because we haven't modified yet, and this is something, it's not in the tutorial, this is something, it's additional information I'm telling you. Do you remember when I created these holes in the features? That's the first hole, that's the second hole, that's the third hole, that's the fourth hole, right? Let me go back to that operation. Which one was it? 1, 2, 3, 4. Because it thinks you need to follow that sequence. By default, it will pick the shortest path and it goes through it. And usually those would be the one which is the fastest, which is the shortest. But it's not always the case. Because it just follow the priority just with that kind of sequence. So that's why in your assignment, is a hint, make sure you don't go by default. The default is the best solution for that. We can have a look. This is something literally you need to process it. So what do you say? You see the 1, 3, 4, 2. No, I think it would be, yeah, if you were to say at least add a zig to it, I would say 1, 2, 4, 3. But for this one, it's quite straightforward. Yeah, Charlie.
So if the diagonal ones are faster, I thought 1, 3, 4, 2, because then you have 2 diagonal ones and only one
Well done.
vertical
Yes.
one. So is that the right way to look at it, or am I missing?
Yeah, but also you need to consider Z movement as well, because the tool needs to come up to make sure it doesn't hit it and go down. So you have those kind of unnecessary move. Not unnecessary, it's related to that one as well.
All right. Okay.
So once you increase the number of Z is good. But there are various things you need to consider, to be honest, because the G00, you're putting pressure on the machine. So both actuator works together. You don't want to have so many kind of unnecessary G00 rapid moves. There's no point of it. So you have to balance everything. So now we're gonna tell you how we can do it manually. Now we're gonna compare it with the AI again. And this is not something in the tutorial. This is something for additional knowledge if you're interested, because I've seen some of you are quite interested in this topic. So I'm gonna go with my manual method. In order to do that, if you remember, I want to change the sequence of those holes. So what I'm gonna do, I'm gonna go to, great. So we'll come back to what I was talking about earlier. The reason that the process that you see, let's say, for instance, these ones, do that kind of process is basically, as you mentioned earlier, because based on the features, it allocates the number of those holes. What the machine realized, that's the first hole, that's the second hole, that's the third hole, that's the fourth hole. And where you get it, if I go to the machining feature navigator, you can see this is how it created those holes. And the reason it picked it like that, because this is how it went through the feature and find those features. So this is a sequence of these features. So whenever you use the knowledge-based feature of the solvers or the AI part of it, you have to come back and think about it. How about the different method of doing it? In order to do that, there are the different way of doing it. One of them, you can go to each single process, go to the toolpath, go to edit, and go to every single sequence of it. The first one comes down, you can see it goes to the Z down, do a drilling, go to the other one, comes down, go to this one. And if you want to change that, you can double click and you would be able to move it around and pick it on whenever you want and click OK and click OK. But I don't recommend this one because there's a better way of doing it. If I do that, let's do it for you. And you can see it as skip the rest because you have to modify everything and you're not going to do that. You don't want to waste your time. So let me make sure I undo it. One of the best ways from the top, make sure you are in the Operation Navigator. Operation Navigator. you go to the geometry, and you, based on how many features you have found, you have them here. A step hole 1, a step hole 2, a step hole, and continue. Each of them, you would be able to go and click on edit, and you see them, a list of them here. So you can see, for instance, this process, that's the first hole, a second hole, a third hole, and a fourth hole, right? If I want to change the sequence of it, you might say, okay, I want to go from here to here, but then from here, I don't want to come here. I'm gonna go to that one, I'll make a zig. So what I'm gonna do, I'm gonna come here to this one, I go down to move it down, and I put it as the fold. So let's go back to the sequence, 1, 2, 3, 4, okay? Before I do that, I'm gonna come here and to check that process. So it's the step hole 1. And then step hole 1, it would be, if I go here, it would be, which one is that? Which pocket is it? It's the first operation that I'm going to do that. Okay, so I remember it. So I go here and then change the sequence of it. 1, 2, 3, I'm gonna bring it down and 4. So I don't change anything else because I want to come back 1, 2, 3, 4. And I click OK. Now you can see these one will change. So if I come here in the program, you can see all of these things will be able to change. And bear in mind the total timing for me 33 minutes. Let's do a generate and click OK. And you can see all of them now pass it. The only reason you see some of them with the warning sign, some of them with the tick, the warning sign means that you haven't post-processed yet. And you would be able to come back here and go and change and check the timing there. If you have a complex geometry, the dimension, if not exactly the same, the numbers will do different. Then what you need to do, you need to go back there. And then if you want to do it manually, for instance, we were doing which one? We were doing this one, but let's do, for instance, this one, for instance. Click on edit. And then do it the different way. Of course, here is 4, so I can have that's one, or I can do the zig. Now you would be able to even change the sequence of it by the AI. So you have the 3 options: picking the closest one, picking the shortest, or the primary direction. So the first direction is started, try to continue with that sort of direction. Let's go with the closest and click on the reorder list. You can see if I do that, it changed the sequence of them. Do you see it? If I go to the shortest, if I click OK, it will go and do the same thing. Because basically these are the full holes. It's the same thing here. However, if it was a rectangular rather than a square, then it's different. The shortest is not the fastest one, because the fastest one you put it when you put in the 45 degrees, once you would be able to do the rapid move, for instance, and also the moving between the different points. So this is if you want to use AI and then compare with your method. And I really recommend it, but make sure every single time you do that, you have to come here and then click on the generate to be able to generate it and make sure it's been saved. So that's that part which I wanted to say about. And do you have any question about this one? Did you have the chance to go through it? This is just the extra if you want to do that, but I will highly recommend if you go to the YouTube, if you search for no, I don't want to. What happened? Okay, so it's my remote access has been disconnected. Hopefully my machine at the university doesn't crash. Okay, good. And if you go to the YouTube and then search for CNC NX hole optimization, I can see these are the different ones, and it tells you which one it's better to do it manually. Then these one tells you manually, they don't tell you how you can use AI, but come back here and then compare it with it. You don't have to, but this is just extra information if you want to go through it. So do you have any questions so far for this one? Otherwise, I'm gonna go quickly through the G codes. Hopefully for some of you don't have experience of the G code gives you more information. We have some set of softwares. First, you work with the CAD. the computer-aided design, the reason actually we have the CAD softwares, because the design process, you come up with some sort of idea and you start a sketch, and then you try to draw it. And before having the CAD software, in order to visualize it, what you're supposed to do, you're supposed to make a scale version of it with a paper, with a wood or something like that, so you can visualize the part. For instance, you can see I have something like that and I have that shape. So once the engineers come up with a computer-aided design, you can see it gives you an option to visualize it better. And that was the first kind of benefits of doing that. Then there was the other sort of issues they had, was that if you have a product, you come up with a design, now you take it to the manufacturing. In order to make sure the product survive in different condition, if it's a breach, or I don't know, if it depends on what kind of product you have, if it's a kind of door handle or something like that, you had to make a prototype of it. You have to take it to the manufacturing stage and make a prototype of it. It's time consuming and it's really expensive. As an example, the time I was in the industry when I was working on BMW, costing the making of the BMW i8, the prototype, was 1.6 million euros, every single of them. Because you don't have mass production, you just do it as a one-to-one, and we're supposed to have 5 of them. Every time I was in safety department, whenever I put it into the crash test, I was losing 1.6 million euros like that. So I cannot say to the BMW, I need 10 cars, give me 16 million euros, and then I want to just waste it to see whether my car survives or not. So what they're supposed to do, they come up with some sort of idea, which is the computer-aided engineering. And the computer-aided engineering, which is something that next week we'll start that when you will learn FEA through this software, how you can analyze it. Once you are sure, once you're 99% sure about it, then you take it to the prototype and put it on actual test. So whenever we put the car into the actual test, I was completely sure that it would survive. And I know what was the weak points, unless I've done the wrong CAE on it. The same things for the manufacturing, I supposed to take it to the manufacturing line. Before the automation came to the industry, what you're supposed to do, let's say if you want to make a 100-hole drilling, and if you want to make it 1,000 of it per day, you need the group of people to go and start the drilling, which takes time, it's not accurate, it's really expensive. So what they come with the idea of the automation in the manufacturing. One of the methods of these automation in the subtractive manufacturing is the CNC machines, which I will talk about it in a second. And you can realize if you want to do it manually, it's really time consuming. Even doing the optimization takes a really long time. That's why computer-aided machining comes in. So I'm gonna go with the kind of manual methods of dealing with the CNC machine. I can realize how CAM was helpful. So in here, a CNC machine, which is for the computer numerical control, you would be able to control the machine by the computer. And the only thing the CNC machine understands is the moving within different axes. So do you remember 2.5, 3, and 5 axes? The only thing we realize, you want to go from this point and that point. Where is the location of that point? How I would be able to do it. And this is what information I need to give to the machine. The beauty of it, CNC become quite well known. There are various reasons for that. First of all, it's fast because of automation. It's you can put a different kind of tools and convert it to a different machine. You can put a face milling and convert it to the milling machine. You can put a drills and make it as a drilling machine. That's why they are quite well known. And also in terms of the tolerances, they are really accurate machines. If you remember, they are more accurate than the the thickness of the hair, for instance. In order to communicate with the machine, they suppose with the kind of language which they call it the G codes, or sometimes the GM codes. So in order to operate the machine, you have to make sure that you go and write that program. And these are the same sort of things you can see. These are whenever you deal with the CNC machines, you have to have a sequence of operations. This one should be a straightforward for you because you already know. First, I need to have a CAD model. What we've done, we imported a CAD model in CAM. The same thing. If you deal with a CNC machine, you upload a CAD model, you put the drawing to it. And then you have to define the material We've done it quite early in the stage of the camp. Do you remember in the workpiece, we went and defined the material? Why the material is important? Because each material has a different properties into it. And that property will impact how much pressure I can put on the machine to make sure my tool doesn't break, my machine doesn't break, and also the workpiece doesn't break as well. Then once I've done that, I have to put the workpiece and hold it in a place. This is where we would talk about as a geometry. We define the geometry, right? And we define the block of material, the bounding block, to make sure how much raw material I have. This is something that in the CNC machine you define. And then I have to tell the machine what tool I want. We create a tool. Do you remember that? And what's the speed and feed of it? And once you do that, then I write the G code, set up the machine. The new generation of machine would be able to visualize it, but the ones for 80 years ago, it didn't have any monitors to do that. And it was just those 8-digit screens. So it couldn't visualize it for you. And you had to just make one prototype of it. But these days, of course, you would be able to test it as well. But for instance, this is the matchmaker machine we have at the university. Whenever you buy it, it gives you this information, how much you can travel in X, Y, and Z. What's the maximum spindle speed it can do? So it's a rotational speed, and and also the feed rate, how fast it can move. So it's a 6 meters per minute. It's along the workpiece. That's the maximum we can go once they both actuated the work together. And what it means by the X, Y, and Z. So that's the positive X travel, negative X, positive Y, negative Y, and also positive Z and negative Z axis. When I write the G code, one of the earliest stage of writing the G code, I have to make the machine 0. This is what we call it, zeroing the machine. But basically what it is, the workpiece that you design as a designer has its own coordination, which is the workpiece coordination. My machine has its own coordination system, which is the machine coordination system, and they don't match. So what I need to do, I need to bring the machine to the coordination of my workpiece, or technically make it a 0. This is something you've done it in the machine coordination system into the software. Do you remember that? The same sort of things you're doing it here. So if you remember these sort of presented, this is something I used to deliver for level 4s. That gives you a better idea. So in here, what you would be able to do, you can see here, that's the machine coordination system, and that's the workpiece coordination system. If I don't zero the machine, and if I tell the machine, go 10 millimeter in positive X, it goes from here. It doesn't do any cutting. So I have to, what I need to do, I have to bring it first to there, make the machine 0, X0, Y0, Z0, and then I start doing the operation. So whenever it moves from there. So that's one of the things we need to do in there. And in terms of the root coding, it's a G54. It would be always write G92, but G54 usually we write it to make sure actually we zero the machine. And then again, there's another sort of things I have to do. Is each, if you remember the CNC machine, I would be able to put the different tooling to it. Each of tools has a different height. It's not only height, also it has the thickness of it, the diameter of it as well. But let's go with the height of it. The machine 0 is this line. That's where the Z is 0. If I put the face milling, this tool needs to compensate it. Otherwise, let's say this is the origin, and if I have the machine, and I'm gonna tell the machine to come down by 10 to remove the part, but if I put the tool, if I say 10 to come down, technically bring down 20, because the length of the tool is 10. So I have to define these to the machine to make sure the tooling is compensated. So what it means, you can see this is the Z home, which is 0, and that's the tip of the tool. The distance between the top of the job from the tip of the tool needs to be compensated, and we need to write a code by the G43 to make sure it's compensated. You don't need to do it in CAM. You just pick the tool, in post-processing do it for you, which is really important. And this is how the G code looks like. And let's go through it. It gives you a better idea even for your assignment. If you want to talk about the G codes, you would be able to go through it. But also it's some sort of information you can get. First is a sequence number. N1, N2, N3, N4. This is something that you've noticed as well. I think Charlie was the one who asked the question. They don't mean anything. It's a sequence number. Line 1, line 2, line 3, line 4. Even if you don't have it, the CNC machine would be able to operate without any issue. The reason they have that number, because the old generation, they wanted to tell you, line 3, there is an error, go and fix it. So they had to come up with some kind of an aligning so you can refer to it, especially if you see you have 1,000 line of the code. These days, it automatically highlights that line in the G code for you, so you can automatically go through it. There's no need for the sequence number, but the way the G code is written, it started with the sequence number. Then you have the preparatory function, the actual G function. If I want to ask you, okay, you need to go to the door and open the door for me, I have to give you the location of the door and what you need to do. The way you move, it's a G function. If you move along the line, we call it G2. If it's you gotta move along the, for instance, an arc is a G2 clockwise, G2 counterclockwise. I will show it to you in a second. And then I have to tell the machine where you want to go. From point A, you want to go to point B. Where is the location of that point B? If you remember, the machine doesn't understand anything. It only understands X, Y, and Z. That's it. So I have to give the location of that one, X, a Y, and a Z. If it's only moving X and Y, I put X and Y. I don't need to put Z. If it's only X and Z, I will put X and Z. It depends on what phases you are working. Skip this one. And then I have to tell the machine what's the feed rate, how fast you need to go to the door to open the door, how fast you need to go. That's the feed rate. What's your speed along moving the parts? So that's the feed rate, I will define. And then what's the spindle speed? Once you reach the door, you're gonna open the door, right? How fast you need to open the door. If you do drilling, you reach to the point, and now you're gonna start drilling. What's the rotational speed? What's how much the tool should rotate? That's the spindle speed. I put it with the S, with a number next to it. You reach the door. How you want to open the door? So you need to have your hand, right? Or wants to do a drilling, you put the what's the tool is required to do. So basically, you define the tool there as well. That's the tool. And also there are the other function you can have. It's called the M function. That's why you call it GM rather than a G code. If you want to switch on the coolants, M07, M08, F0, these sort of things regarding coolant. If you want to make the sub program, do you remember that? You create a sub program and I ask you to remove them, print it to the higher level. These are all related to those. If you want to, for instance, if I remember correctly, I think it's the M98 is for the sub program, these sort of things. If you want to put it into the loop, that you're gonna go and continue to do some sort of activity, use those. There's one more thing you need to consider. If there's an arc, you know you're gonna move from point A to point B. Let me show you to in a second. Let's say you're gonna go from point A to point B. Because it's an arc move, I need to give the location of the point B, right? I need to write the X, the Y, and Z of it. But you might ask me, okay, Esfandiar, which one should I pick? I might be able to go with this arc. I can go with that arc. The only difference is the radius, right? So I have to define the radius. The machine doesn't understand the radius. The machine only understands X, Y, and Z. It only understands coordination. So in order to engineers come up with a solution to it, they come up with the idea of giving the coordination for that center point. It has X, Y, and Z. But if I use the X, Y, and Z again, the machine gets confused. That's why they convert it to the I, J, and a K. I equivalent to the X of the center, J is equivalent to the Y of the center, and K is equivalent to the Z of the center. It's the same thing. So because here it was a G2 and arc move, I have to have the destination and I have to have the center point. Is it clear? This is just additional information. Good. I'm sure Eric, you knows that. Thank you so much for responding. And so let's go more. Okay, there are two different methods of the programming. They started with the G19. I will tell you why it started with the G19. G19 means every sort of move would consider from the point that you just make it as a 0, x0, y0, and z0. So every move you do, you forget your current position. You always consider from the 0, 0, 0. The reason they went with that G90 program, because the amount of memory and RAM was quite expensive at the time. They couldn't hold this information, so always the machine will forget that. So that's why they use the absolute programming. The majority of the codes is written in absolute programming. That's why even in the post-processing, once you got the code, you can see it was G90 on the top. So the absolute programming, you will have the origin, let's say x0, y0. So I'm gonna go operation x on y. This one is the x, and that's my y if I want to convert it to the axis. So now what I'm gonna do, I'm gonna go from point origin to here. So hopefully if I can change this one to the pen, that would be better. Okay, to this one. So what I write, the language is G90, so I write G90, and x is 40, and y is 90. You can see it here. G90, x40, y90. If I'm gonna move from here to this one, the actuator is still there, but it forgets the position. So I still consider from the point 0, 0. So the x would be 80, and a y would be 30. You can see I write x is 80, y is 30. So if I'm gonna go from here to there, and it's this one, what should I write for x? Any idea what should I put for the x?
Sorry, which one was it?
So I want to go this one, this point.
Oh, that one. So it's y 80 and x 120.
Well done, exactly. So you have it always from the 0. Thank you so much, Eric. And the same thing, if I'm gonna go from here to there, x is 160 and y is 50. And you can see it there. However, the developers come up with a new language which been added later. It's the G91. It's incremental. And I will tell you why and when they've done it. Incremental, it remembers the position it has. So you're expanding the memory. And there are the benefits of using the incremental tool. So if I go from here, the origin to this one, you can see x is 40, y is 90. Because I'm using the first one as an absolute, I write it G90, x40, y90. Because that was the first move. Every single of CNC machines, the first move is a G90, and also it's a G00 as well. And I will tell you what's the G00 in a second. If I'm gonna go from here to this point, the second point, and I'm gonna use the G91, sorry, I will see how much I traveled in X, Y, and Z. So how much did I travel? I traveled in the 40 in positive X. So I write G91 first of all because it's incremental. X40, but I'm coming down in a negative Y direction by 60. So I'll put Y minus 60. So remember my position. Let's say the next point. Can you tell me what should I put for X and what should I put for Y, please?
X is going to be plus 80 and y is going to be minus 10, I think.
No, I think
Okay.
like 40, 50.
Okay, what's the reason for that? Do you want to say? It's 40 and 50. Why?
Yeah, because this one is incremental. It's increasing. It's from the original point, but instead of putting the whole number, you just like dividing them. Like since the first one was 40, you add 40 to it again. That's 80. But you add 40 again. That's like 120.
Exactly. Yeah, well done. So what it does, it remembers the previous location. So what I will do, I will go in a positive 40 in X to reach that point, but I'm coming up as well by 50. So I'll put the Y 50. The same things for the next one. If I want to go from here to there, I go positive 40 in X. However, I'm coming down by minus and 30 in the Y direction, and that's why I write it like that. The reason we use incremental, first of all, whenever you use an arc, doing the radius, the only when you would be able to find the radius is doing the incremental, because I want to see how much the distance is. The other things, if you want to put, let's say you have 100 holes, you're going to do a drilling. If I use G90, you need to have at least 100 lines of code. Every time the X will change, right? Let's say the holes are next to each other. If I put the incremental every time, I will add 40 to it. Let's say every time this hole, and that's the next hole, and next hole. So every time you add 40 to it, then I can write it in a way that I can put it in the loop. So that's why the incremental came to the market, and they started working with that. Next slide, these are the common G codes. And if you want, even you can take a picture of screen, or once you save the video, you can go through it. Even if you want, you can use it for the assignment. G1 is a line motion, a line motion. A G2 is a clockwise arc. A G3 is a counterclockwise arc. And then this one, which one should I say? For instance, G90 was the absolute programming. G91 was the incremental program. There's the other thing is the G0, which is the rapid motion. A rapid motion, when I discuss about the optimization, you've heard from me that it started G0. So what the G0 does, and this is how the G codes looks like. And in the post-processing, you've already seen it, so I don't go through it. Whenever you say a G1, a line move, for instance, it takes the shortest route, because it wants to go from the point P to the P2, but it's not the fastest one. If I want to go with the fastest move, I use the G00. Rapid move put in the fast possibility of the machine to work alongside the part. So all these actuators, they work together. They're putting much more pressure on the machine. But in order to do that, because both gears are going to work together, and it doesn't want to lock it, it put it in the 45 degrees and then put it as a 2 move, not 1 move. So what it does, it goes like that and goes like this. And you can see it's a G0 rapid. Whenever you've seen, I would recommend to go back to the video that Diana and I showed to you about the CNC machine. You can see one is do the cutting. For instance, if it wants to go from here to here, then it go up and do it fast. What it does, those kind of fast movements, these are the one that we have it as a G00. Yes, Eric?
Is there a difference between G0 and G00? So 1, 0, 2, 0?
No, it's the same things. G00 is the old version. G0, they come up with it. But if you do both, they will accept both. The machine, but they will accept both.
Right, okay, thank you.
You're welcome. And the reason, if you know it, so the way you program is a 0 and 1. And then when they build the computer, because they go with the G01, G02, G03, so they had to have that digit. But these days, G0 do the same thing for G00. Great. So that's the other thing. Something remember, for G00, it's a non-cutting move, because I cannot put the pressure on the machine to go and do it as fast as possible while you're cutting. It will damage the tool. So the machine will do that. That's why in the cam, it automatically realizes, so the G00 is a non-cutting move, rapid non-cutting move. And that's why if you compare with the zig and a normal in the closest, if you have the line, if you have the rectangle, the result must be different. In our case, because it was the score, it didn't change it. But these are the things you need to consider for your assignment. Some points, it would be able to change it once you do the zig process. There's the other thing of that I want to mention. How do you do the arc? So this is the P1, and I'm gonna go from P1 to P2. So why I write it G02 because it's an arc. It's a clockwise arc, right? G02. I have to give the location of the P2. A P2 location, X is 82, Y is 68. So I write G02, X 82, Y 68. That's the Y, that's the X. Then I have to give what's the center of it, because that center gives me the radius. In order to do that, what I will be able to do, I would be able to find how much distance I traveled. And I have to do it with the P1, the previous point. So what I will say, for the center, because I've done that arc, right? I've done that arc. I move from the P1 to that point. The center, if it's here, so you have a move in an X direction by 27 millimeter, but you're coming down in a Y direction by 42. So what I write? X 42, Y minus 42. But if I put X and Y, the machine get confused. So I have to write I 27, J minus 42. And also I put the fit rate, whatever is that. That was the part, probably if you've done the assignment for EG4010, it was tricky for you once you're doing it. And this is why it's a little bit complicated, but the rest of G code is quite simple. Let's do this one, a quick example quickly. I will highly recommend, if you haven't done this activity, do it at your home if you want to understand the G codes better, and contact me if in case you have a question. So you can see once I set up the machine, it go with the G54. G54, what was it? It was the, you're making the 0, right? You're making the machine as a 0. So you make it G0, G54. How you 0 it? You want to do it as fast as possible. You don't want to cut anything. So I put the G0. Usually this is the first line of the code in the CNC machine, G54, G0. And I will find the points that I want to go there and make the machine 0. So assume that's the X and assume this is the Y. This is the XY plane, G17. So you find the first one. The next one, what it does, is doing the tooling compensation, G43. And in order to do that, to make sure that actually the tool doesn't hit it, goes up in the Z. You can see that. So I jump from the Z because it's XY plane, I cannot showcase it. And then in here, I have the G1. What was the G1? Do you remember it?
G1 a straight line movement, I think.
A straight line movement. Well done, Eric. It's a line movement. So I should expect to have an X and Y. So in this case, X is 50.67, Y is 90, and I have the fit rate. So I'll find that point, 50 and 90. And as your friend Eric mentioned, G1 is the line motion, so I will connect them as a line. Technically, the machine would do it, for instance, find this point and do a cutting in here. Next one is a G2. Yes.
Just to recap, you said that we're skipping Z because it doesn't apply to this situation, right?
The reason we skip the Z in here because that's the XY plane. That's the X, that's the Y. I cannot show the Z. But of course, in reality, it goes up, right? So I need to have a different plane. I'm just trying to do a drawing, 2D drawing, let's say. So the G2 is an arc. So for our arc, I would expect a P2 from A, you're going to go to second point and a center point of it. The first one was absolute. So from the point 0, 0. You find point 60 and 90. If you notice, Y is constant, Y didn't change, so only X is changed. So find that point. However, I and J, these are incremental. In order to do that, I have to see how much I traveled. So what I've done, I traveled positive 5 in X, that's why I is 5, and negative Y for 3. So I should expect to have the point from here. So positive X, negative Y, and that's the center, because this one is incremental, it's not absolute. And then I will make it as an arc. And I will continue with that. I don't want to bore you with it, but you can see that it will continue with this one, do an arc, and each of them I have to find out what's the radius in order to be able to do that. And then at the end, something that you can check. This is one of the methods of writing, checking your G code. The next line, which is here. These X and Y, is it familiar for you or not? Do you have X21 somewhere?
It's the initial starting location, the home,
Well done.
home position.
Yeah. So come back to where you start, and this is how you can check your code is correct. Because I want to finish the process, and you can see here I'll come back to where I started. And in here, the next one, you can see it jumps in the Z, ups, because it wants to do operation inside the part and doesn't want to remove something. And you do it as fast as possible. That's why you use the G0. I'm referring to this line. And then go to that point, which is inside, and that's why we highlight like that, because it's a non-cutting move. and comes down because he wants to do operation, and then in here's the G3 counterclockwise, but because this one X and Y is the same as where it's started, rather than having an arc, it's a full circle. So this is something you could go through. I don't want to go to the depth of it because technically you don't have to know this, but it's the additional information. It's really good to know. This is the reverse way of doing it. This is, I gave you the G code to do it, but now let's see how we're gonna write the G code. Writing a G code for this G clamp, which you made last year, hopefully in the workshops. In order to do that, usually you have, let's go to the next page. Usually you need to create something like this, that I need to specify the marks I'm gonna move to each of them. And each of them, I would be able to get it through the dimensions. So you have the CAD, you know those. But which you would be able to do. X and Y is quite simple. You will be able to do it. However, for the arcs, it's tricky. You need to find the radius of it. You know the radius. You need to convert that radius to the point. Let's see. I'm gonna do this one quickly, for instance. For where is the mouse? Okay. For this one, this is outside. I'm just coming here and make the program 0. So I write it as a G54 and then a G0. And then from here, I go up. So I just put X and also the Y. X is the same X, but Y is changing. And also between C and D is okay. But if I go from D to E, it becomes tricky. Why? Because once I go from D to E, and I know it's a G3 because it's counterclockwise. Location of E, I know that distance, and I know this distance as well, so I can give the X and Y of E. But finding that center, I have to make an imaginary triangle here to do that. And this is why if I go to the previous pages, let me exit the presentation, it would be able Discord. I have to go with the imaginary triangles first in order to do that. These triangles give it the center point of them. So you have to go with the trigonometry. So you put the hypotenuse and then do the trigonometry to come with these. Once you come with that, you complete this one. And once you complete this one, what you need to do, you need to add the tooling compensation. And I think the tooling compensation, yeah, here, because the diameter of that cutter is important, how much material you remove, right? That diameter is really important. Calculated those, remove those from these numbers, and then start writing a G code, and it would be like that. That's for the G clamp. Time consuming, a lot. It's a lot. So I will come back to where we started earlier. That's the code you got for this part that you just made. We go through it one more time. Sorry, that was the setup. Do you see how many lines of code? If you want to write this one, it takes ages, and this is what the technician used to do. Cam, sort it out. Once you set up everything digitally, and then there is tooling compensation, these sort of thing, everything software take care of that. So these one that I did, hopefully now you have a better understanding about the G codes, and you can always go through my video if you want to practice it, and you can now realize how the software is powerful and how much it saves your time. Yes, Hussein, it's wow. Yeah, thank you. Yeah, Eric, do you have a question?
Just want to point out, I think if you scroll down all the way, it'll actually tell you how many lines of code, like the last line in the G code.
Oh, yeah,
it tells
in the
you
end, yeah.
Yeah.
4,007, yes, yeah, exactly. Yeah.
So quite a lot.
4,750, and time consuming, but again, you might do lots of mistakes in here. And especially if they're in the early ages, they couldn't visualize it. So you had to put it into the test and see whether it's breaking or not. So that's what CAM is really useful. For the part of assignment, I will recommend pick few lines of it. You can pick a specific section and then talk about it. Now you should be able to do it. You have the template of those G codes and explain. Now it would be quite straightforward to go through them, you know, where you set it, where you use the You understand, for instance, make it a 0 as the G54, G43 tuning compensation, or a joke that Eric done G28 going back to the home was saying after the lecture. Yeah. And knowing that it will give you much more information about the post-processing basically, and you can realize how CAM was useful for you. And even these days, although they trust NX, but because if you define something incorrectly, for instance, if making a 0 was incorrect, the rest of the code is incorrect. All the code, all these 4,000 lines, it's wrong. And the reason for that, because the moves that you have is not right. So doing those sort of setup is really important. Usually they pick a section and then go through it, a few lines of it to see what it does, whether we come back to the same sort of points that actually we started or not. And this is something I wanted to mention for you. I've already told you how we can do those sort of optimization. Please spend some time to compare with what you think, what the machine thinks, and then you can even put in the discussion. Machine doing better, or you do better, which one? I'm sure whatever you do, even your case or the machine optimized version is better than what we use as a knowledge base, the default one. In terms of timing, my timing didn't change for the optimization when I was doing it, because when I changed it from the normal to the zig, it didn't change because I didn't give the feed and spindle speed. In your case, you already have the feed and speed in your assignment. But please make sure to elaborate, to talk about it. What was the method of thinking, what you've done, so we can realize you just didn't go take the features, make the operation, so you know what you're doing. So I will definitely ask you to please write a few paragraphs about those sort of things while you're processing. So that